Welcome to another RDWorks Learning Lab. Now today I'm going to be looking at a problem with my new Think Laser machine. Now I say a problem, it's not the sort of thing that you would normally expect to find on the machine. It's been inspected, it's been tested, but the sort of issue that I've come across is you would think that it would be obvious to find, but in fact you have to be doing a certain type of work before you realise that there's a problem with the machine. And I suspect that most of the test programs that Think Laser in the UK put to this machine were not quite broad enough to pick up this issue. So it's a learning curve for them, and I'm sure that they will deal with this problem in future, especially now that I've pointed it out to them. I was generating my Christmas cards here. Show you what I mean. When I folded the card in half down its crease line, what I found was I was not getting a perfect fold. Let's just turn it over and you'll see what I mean. We've got some sort of squareness issue. The lines are not square because the folds are not matching. So that set one or two alarm bells ringing, and I started to look closely at the machine. I've got a piece of 10mm perspex here which has just been machine cut on a saw, and across the diagonals 651mm that way, maybe 650.8. so as near as I can tell it, this is a block of material that is square. Now it hasn't got a very good edge on it, but it's square. That's the key thing. And all I'm going to do is to sit it on the ridge against the rail there, like that. And I'm going to pack the other end up so that it's approximately the same height. And look, as near as I can, what I'm going to do, I'm going to slide this piece of plastic back until it touches the air fitting, which is doing just there. And now I'm going to move it to the other end of the machine. So basically I've moved that point from here to here 440mm, and I've got a change. I've got a gap now of 2.82mm here, and I had nothing down at this end. So that means that that beam is a long way out of square. I'm going to have to be a lot more thoughtful about how I'm going to physically push this beam back into line. I've got to have a little bit of an investigation to find out what fixes to what. Now because the bearings are fixed to the rail with 4 screws, I can't just twist the rail because I should be twisting the bearings. So I've got to slacken the bearings off. And then I've got to slacken that drive belt off on its shaft so that the shaft can move relative to that shaft there. In other words, these belts are out of line. They need to be lined up when I move this. And it's the beam that I've got to keep an eye on. So let me have a quick measurement of the overall beam length, because that's what I've got to adjust. So before I take this rail apart, I've got to set up some reference points here that I can work with. Now I happen to be lucky enough to have all sorts of bits of kit in this workshop. So I've been able to bolt a little plate on there which enables me to pull this beam forward onto it. So now I know that that represents 0. And at this end here, when I put the other plate on, I shall just modify this dimension slightly because it's no longer 740. So that's 708. So instead of 740, it's 708, and that would make this one, so that's 708, divide that by 440, 440 equals times 2.82, 2.82 equals 4.54. Well, that's about 4.7, so it's only 0.16 out over that length. I don't think it's going to make a huge difference, so let's set to that as a reference. Okay, well we're ready to dive in now, and to be honest, this is the only piece of tool kit that I've been supplied with in the toolbox. That won't get me too far, so I think the first thing I've got to do before I get stuck into this machine is to loosen off the belt tension, and I have to do that just here. So there's a tie wrap there which stops me from adjusting that one. Well, that slackens the belt okay. And okay, now that I've got that block removed, we can see these 4 holes here. 1, 2, 3, 4 holes, which are in fact the fixing holes for the bearing block. So if I hunt around in there, I should find the screws. So I shall have to loosen those off, and they are pretty tight. Okay, now before I do that, I've got to remove this end panel off the machine here, all using the same key, which is good news. I can just drop that panel down so that it doesn't get moved. They have supplied a smaller key, and with a bit of luck, maybe just loosening off these 2 grub screws here will give me the belt float that I need, unless they're locked in, and they might even be, goodness me. The problem that I've got here is that I can't, these grub screws which seem to be fixing this pulley onto the shaft are so solidly locked in there, I'm afraid I'm going to damage them. So the first thing I'm going to try and do is to undo this nut that's on here to see if I can put let some tension off of it, because it may well be that it's physically locked in place. Now I can put a spanner on here, which is a 17mm spanner, but the problem is I've got nothing to lock it against. As I move the spanner backwards and forwards, there's no other mechanism on here like a Tommy bar hole or anything like that for jamming it against anything. So I've got nothing to work against. But at the other end of the machine, we've got the other end of the shaft just here, and I've got a spanner. Yeah, I've managed to get it on. So what I'm now able to do is to jam that spanner against the base of the machine and move the other one up. So I've got some leverage against the 2. I can use one against the other. Now which one will loosen first is debatable. Right, I think before we try fiddling with the belts and adjusting them, we'll just remove this other block from here. So this one's got 2 tensions on it because it's got the tension of the motor block as well. So we should now be able to take this belt off here and slide this out of the way. And now as I poke down there, I can feel I've hit some wires, so I've got to hunt through there to find the screw. There we go, we found it. And we loosened it. Well, at least the bearing is loose now. Well, we've now got to do the same for this bearing block here. There we go. That was lucky, we found those 4 quite easily. That was the tightest one that had a little bit of a click on it. Right, so that means now the whole of this head is technically able to be moved. But the problem will be I can't move it. But because it's a tooth belt, it's the teeth that have got to move relative to each other on these 2 sprockets. And that's what I can't do at the moment. So let's go to the other side. I've got the nut off of here and I've got these loose. The grub screws are well and truly away from the shaft. We've got some movement on the shaft there, look. So the fact that I've been able to lever it out of position means that now I've probably loosened it on the shaft. So I might be able to get the movement that I'm looking for. So let's just see whether or not I can get a very tight fit on there. Oh, yes, I can. Yes, I can. I'm getting the relative movement that I'm looking for. You'll see that I should be able to use that Tommy bar. And look, I can move this backwards and forwards. And let's see how much I need to go to close the gap at the other end. I've got about another 2 or 3 millimeters to go there. And I've got 0 gap there. Okay, now I've not locked anything up, but I'm taking these off because it's so stiff that it's not going to move. And what we're going to do now is we're going to put my squaring mechanism up and check it before I tighten anything up. Let's just try one more time. Well, I would say that that is just about perfect now. So over about 450 millimeters we've got perfection. So can't do much better than that. Jam that in there. Then we'll tighten this nut on the other end of the shaft here. Right, so we just lock both of these grub screws back up. Now I would say that that screw hasn't gone in as far, and it may well be that there was a drilled indent in the shaft, but it's not getting that now, it's just getting some extra welly. So the first part of reassembly is to tighten up the bearing screws. Okay, we've tightened up the bearing blocks. And it still feels fairly smooth. There doesn't feel to be any resistance there. I think we'll put that bearing block assembly on first while we've got the maximum amount of slack. So let's see how we're going to do this. We're going to put this one on first. There's a line on there, but that line doesn't mean anything. I thought it lined up with a bearing block, which it does on the other end, but this end it doesn't. Okay, now the one closest to this is the one I'm going to tighten up first. What I'm now going to do is to push that bearing block forward as far as I can to put tension on this belt here. Tighten it up. Yeah, that feels nice. So we slip this other bearing block on. To be honest, there's so little slack in there, I may as well tighten them up properly, because I don't think it's going to make any difference to the tensioning at all. We're 90% of the way there now. All we've got to do is get the belt back on and tension it up. Once I get the screw threads in, I can tighten them up with keys. And it looks as though, oh, that's not too bad actually. That's not too bad at all. Actually, this is quite a nice adjusting system, to be honest. Right, so now finally we've just got to reinstate this cable tie. No, first of all we've got to just, before we put the cable tie on, we've just got to put the lock nuts. Now one final thing that we must check is that this cable comes nowhere near that sensor. I've tightened everything up that I should do. That's fine. I think I've done everything. That belt's nice and snug. That belt's nice and snug. Close the covers up. One major problem. There's no point in going for a burn, is there? Or is there? The mirror is mounted to the beam, so it's possible that the mirror is still in the right place relative to this. So we better just drive it forward. Yeah, well that beam is off now, and it's not in the middle there either. So I've got to reset the beams. So we may as well do that from scratch very quickly. Shouldn't be difficult. So whatever the settings are here, basically they don't mean anything to me. Well, the purpose of this session is all about the squareness issue, not about calibrating and setting the beam of the machine up. So I'm not going to go into a great deal of detail on this, other than the fact to say that I've been using my target holders and my targets, and we're going to just check out the final result that I've finished up with. So I'll just do a quick pulse on there, and that's not too bad. It's pretty central, and it's within the central target area, which is what it's got to be. And we do one test right at the back of the stroke, which is where it is at the moment. And we should do a test at the front of the stroke, and we see they're not perfect, but they're not bad. And finally we would do one at mirror 3. And that's its front position. And there we go, those are the two positions. Nothing special about that beam setting, it's middle of the road. It's not perfect, but that's something to be done another day. Let's put some extraction on, hold that paper down. Now we're running a special test program that I've just written. Now this is just a sheet of, it's a cartridge type paper for drawing on, but you could use lining paper, wallpaper, lining paper, which is quite a thick paper, and it's also quite cheap. But it's a very convenient material for carrying out tests like this. And so we'll just run the file and I'll show you what we finish up with. Now, did you hear the note change there? It's now gone very quiet. The cut has gone quiet. Dimensional check across the diagonals. Well, it's certainly 5 or 6, 61. I'm going to call it the same, 651.5. And this dimension across here should be 550, give or take about 0.2 2. I'd say that's 549.8. It's just a smidge off of 550, and it should be the same across the bottom here. 8. And down the side should be 350, spot on as well, 350, which it is. Maybe 349.8, maybe, but it's close enough to 350 to not worry. And of course the final check that everything that we've measured is correct and that we're not cheating is to fold the thing in half, because if this folds in half along my perforation line, then we should have perfectly matching corners. Which we do have. We can't see any overlap on the corners whether we look this side or the other side. So we've transformed that machine from non-perfection to perfection, both dimensionally and squareness wise. Dimensionally it must have been pretty well correct to start with, so the calibration of the machine was good, but it was just a squareness issue. And there we go. So at the end of the day, a program as simple as this will tell you whether or not the machine is running right or not.